Right, hi, assalamualaikum. So this time we will do a problem on adiabatic, and basically this problem is a gas, right? So let me see this question. A gas is compressed irreversibly from 100 kPa 70 degrees Celsius to a pressure of 0.5 megapascal at 77 degrees Celsius in a perfectly thermally insulated cylinder. The work done on the gas during the compression is 45 kilojoule per kilogram. Determine the value of CV, R, and also K. So here, the first thing that you need to know is to highlight the system here. This is our substance, which is a gas. So we treated this as an ideal gas. And we also can highlight here the process involved. This is a compression. Reversibly from 100 kPa. Also, this is important properties. The pressure of another new pressure. So now we have two pressure and two temperature in a perfectly thermally insulated cylinder. So this is indicate that this process is a adiabatic, right? Perfectly thermally insulated cylinder. So now basically we have two process, which is the first one is the compression, and it is coupled with the adiabatic process. Okay, determine the value of CV, R, and also K, right? So let me see here. We have already highlight the important parts here. Then we need to identify the problems. Okay, so first identify the system. We do the procedure as usual. The system basically is ideal gas, right? So this is inside the cylinder. So that we can treat this as a closed system. Okay, and then we need to identify how many states do we have to deal with now. We have one here, okay, and then the pressure becomes P2 here. So this is your T1, this is your T2. Okay, so basically we have two states involved. Then identify the process. What is the process here? The first one is the compression. Okay, compression. The second one is your adiabatic, since the question state insulated cylinder. So compression plus adiabatic. And then the next thing is to illustrate our problems. So this is a perfectly thermally insulated cylinder, and it can be compressed. I can set this as a piston cylinder device. Alright, so you can compress it. So first, just put here a line. Okay, since this is a compression, I will do to illustrate it in a better manner. Okay, so inside this we have ideal gas. Then we do a process. I can just copy it. Okay, and then the volume is reduced due to the compression. So means that if you calculate the work, you will get a negative value. Okay, so since this is a gas, and now you can detect what is the process involved, and then you label which one is the state 1 and also state 2. Okay, so this is the process. Sorry, it's a compression and also adiabatic. Okay, so this is state 1, this is state 2. Okay, and then you can list out the properties. This is our step number 5. T1 given as 17 degrees Celsius. Since this is a gas, I will just convert it into Kelvin. It will become 290 Kelvin. Then P1 is equivalent to 100 kPa. Then your T2 is equivalent to 77 degrees Celsius. This is equivalent to 350 Kelvin. Then your P2 is equivalent to 0.5 MPa. So this is 500 kPa, right? Okay. So next is we have put all of the 5 process system, state process, illustrate the diagram, and also list out the properties. The next is to analyze the question and then answer the question, determine the value of CV, R, and also K. So here basically this is a adiabatic process and also the compression. So it asks you to find the value of K, R, and also CV. Okay, so basically in order to solve this problem, it don't ask you to find the work or the heat that usually asked before, right? So it asks you to find the value of the properties of the gas, since we did not know what is the name of this gas. So we can use several questions related to the adiabatic. For example, here it gives you the value of CVR. Sorry, it gives you the value of the work done on the gas during the compression. So if the value is 45 kilojoule per kilogram, so this is basically the work per unit mass during the compression process. Okay, so how to describe this in the mathematical expression? So 45 kilojoule per kilogram is the compression work. Okay, so for a compression work, this in term of the work net will be a negative value, since this is compression. You will get a negative value since this is a compression. So in order to put this 45 kilojoule per kilogram, which is basically the work per unit mass, okay, this is equal to negative value of what is the amount. So if the amount is 45, you need to put here as minus 45 kilojoule per kilogram. So this is how we want to express this, or you just can write it as a small w. Okay, to work it. So this is the first thing that you need to write. If you write the work net as a positive, for sure you will have the wrong answer. Okay, now we will continue to solve this thing. The work net is equal to minus 45, and we can use the equation related to work net. Okay, so since from the first equation, or you can use because the work equation, but we can try first the what we call as a first law equation, which is a Q net, or before this I always write in terms of big W, right? Q net minus work net is equal to delta U. But since this is a small w, we can translate it into small q and small delta U here. So per unit mass basis, this is becomes Q net minus W net equal to delta small u. Okay, so this is a per unit mass, kilojoule per kilogram. This is a kilojoule. Right now, for an adiabatic process, we know this should be equal to 0, since this is adiabatic. So what will happen here is your negative work net is basically equal to delta U, and this W net is equal to minus delta U. Then you can put into the equation, expand delta U is negative CV delta T, and this is equivalent to negative CV T2 minus T1. And then you can put also the work net value here, which is negative 45 into this equation. Negative 45 kilojoule per kilogram equal to CV T2 minus T1. So here you can get the value of CV by rearrange the equation. CV equal to minus 45 divided by minus T2 minus t1 here. Then this is become negative 45 this t2 just now we get as 350 minus 290. 350 Kelvin minus 290 Kelvin. The above one is a kilojoule per kilogram. So you will end up with kilojoule per kilogram dot Kelvin. Then by pressing your calculator, basically you can get the answer. So this is equivalent to 0.75 kilojoule per kg dot Kelvin. Okay. All right. So the next thing, for the value of R and also K. Okay. So since we already used the equation of the first law, we can also use the equation of the work. But if we put that into our problems, which is W is equal to P1 V1 minus P2 V2 over K minus 1. So we will end up with a lot of variables, which is we did not know the value of V1, V2 and K. So this is a 3 unknown that we will have if we use this equation. Besides, if you just translate it into MR T1 minus MR T2 divided by K minus 1, and now you will also left with the value of R and also the value of K, which is 2 unknown. Okay, so since this is not help on the adiabatic problems, most of the time when we deal with the adiabatic problem, we need to use the adiabatic equation, which is either you use the P1 V1 power of K equal to P2 V2 power of K, or you can use T1 V1 K minus 1 equal to T2 V2 power of K minus 1, or you can use T2 over T1 equal P2 over P1 power of K minus 1 over K. So this 3 equation is valid only for adiabatic and ideal gas. Okay, so if this is not a gas, so you cannot use this kind of equation. So in order to select the appropriate equation, you need to look what if is the least unknown. Okay, so let me check one by one here. We have here P1, but we do not have V1, we do not have V2, and we do not have K. So it means that we have 3 unknowns here. Okay, so it will not help you to solve the problems. Let's check the second equation. T1 yes, V1 no, K no, and so T2 yes, V2 no. So also same 3 unknowns. How about the last one? T2 yes, T1 yes, P2 yes, P1 yes, and then we only have 1 unknown here. By using one equation, one unknown, you can directly get the value of K. So we can use the third equation. Okay, so since this is the selected equation, you can put the value here. T2 over T1 is 350 over 290 Kelvin is equivalent to P2 is 500 kPa over 100 kPa. So make sure the unit is consistent. Alright, so this is K minus 1 over K. Then you can simplify 350. So I just put here 1.2069 equal to 5 power of K minus 1 over K. You can put ln or you can put log on both sides to solve the problems. Ln 1.2069 equal to ln 5 K minus 1 over K. Then this is equivalent to K minus, put it step by step. K minus 1 over K can be put at the front of the ln 5. then you just rearrange back k minus 1 over k equal to ln 1.2069 over ln 5. So this is, just press the calculator, ln 0.1168. Then you can rearrange k minus 1 equal 0.1168k, 0.8832k equal to 1, k equal to, say, 1.132. Okay, then you get the answer. The last one, we left with the value of r. Okay, so for r, you can use r equals Cp minus Cv. Okay, or you can use, since we did not know two unknown here, which is what is the value of Cp and r, so you can get Cp first using the another equation, k equal to Cp over Cv. So this Cp equal to k Cv, and then you can just put this into this equation, rearrange back, you get r equal to k Cv minus Cv. This is equivalent to Cv k minus 1, which is now we get the value of Cv, right, 0.75. K is 1.132 minus 1. So this is our r. Get here is 0.099. 0.099 kilojoule per kg dot Kelvin. Okay, so this is method to solve problems on the ideal gas equation. I put on the same page here so that you can refer it later on. Okay. Right, I think that's all. So this thing, just want to make it nice. Okay, we can make it smaller. Right, so that's all on the adiabatic problems. Next, we will also look into another problems. Okay, thank you very much. Assalamualaikum.